Today we're going to model a 10 centimeter annulus with a channel of steam through the middle. To save on time, I have modeled the annulus and the steam geometrically already, and I will just be going through the process of creating regions and assigning inlets and outlets and physical boundary conditions and meshing. For splitting by patch and scene creation, continua creation, and other things, part creation, watch some of my previous videos. Alright, so as you can see, split by patch has already been done. It's a very important step because the different surfaces are going to have different physics. So the first thing we need to do is we need to create contacts between these two parts. So we're going to select the two using the Shift key. We're going to right click and do a Boolean imprint. We're going to change this Boolean mode to be CAD, and we can leave the tolerance as is, and we're going to click OK. So what that did is created contacts between the inside and side patches of the annulus and the steam. So now we can set those to interact thermally in the simulation. So once we've done that in the split by patch, we're actually ready to create regions. So we're going to assign these parts to a region, change these first two options, apply, close. Now I actually failed to create a second continua, so we're going to create a physics continua for the solid annulus, and this is going to be three-dimensional. It will be solid. We're going to do steady state, and we're going to use solid energy. We're going to use a constant density, and that's all you need to do. This defaults to aluminum, and that's fine for this example. Now we have our two continua and our two regions, so first thing is we need to change this continua to be aluminum instead of steam. It should be noted that the steam continua, you had to select water as the material, so that's important. It defaults to air as a gas continua. So with those properties set, we can go into the steam part, and we can set the inlet as a velocity inlet and the outlet as a pressure outlet. These are two commonly used boundary conditions for forced convection flows. The sides are going to stay as walls, and this is the interface that we created from the contacts earlier. So that's about all we need to do for the let's see, the physical conditions. Sorry, we forgot to set the physical values of the inlet and the outlet. So we're going to set this just to make sure we're really moving. We're going to set it to 2 meters per second. That should be fine for this example. And let's set the steam to be at 400K. And these flow directions, or everything here is fine. The outlet, we will need to set the static temperature of the outlet. We will start with that at the static outlet, we'll say, is around 400. That may need to change later. Alright, so we have our steam boundary conditions set. And that should be at the aluminum. We won't need to worry about unless we want to set a cooling condition on the outside, which I think would be interesting, because otherwise this part will just heat, everything will heat to 400K. So let's, for the physical condition, or we go to the boundaries, we go to outside, physics conditions, thermal specification. Just for simplicity, we'll set a temperature boundary condition, and let's set the outside to be a constant 300 Kelvin. Just like that. Alright, so with that done, we are ready to mesh. It's important to change some of those parameters, such as the inlet and outlet identifications of the steam part, because that changes how the mesh will perform around those parts. So we're going to create an automated mesh, select both of these parts. We're going to use a polyhedral mesher and the prism layer mesher and the surface remesher, and that's it for now. We go in here and we're going to change the controls, the base size. This is about 10 centimeters long and about 4 centimeters in radius. So we're going to set the base size to be about 3 millimeters. The target surface size we can leave as default, same as minimum. All of these we can leave as default. Prism layers we are going to change to be 10, which is typically you might use between 10 and 20 for convective flows. Prism layer total thickness, we're going to change that to be absolute, and we want it to be about, if the radius is 4 centimeters, let's have it be about 0.75 centimeters. These can stay as the, well, let's change that to be 1,000. Alright, so we should be ready to go. Now we're going to change this to be parallel. Didn't mean to do that. And now we're ready to execute this mesh. So we'll be back after that's done.